Okay, let's begin a series of videos about polynomials, alright? So, what is a polynomial? So let's talk about the characteristics of a polynomial. So, first of all, polynomial has one variable. Alright? Now, be careful here. When I say one variable, I don't mean you only see a variable once in the equation. I just mean there's only one variable in the equation, so x, and all you see is x. It's not a mix of x's and y's and etc., right? So, like here's an equation using my function notation, right? So like 3x to the 7th minus 4x to the 3rd minus x plus 10. Now you see x 3 times, but the variable is just x, right? So polynomials have one variable, so that's a characteristic of a polynomial. The powers are whole numbers. Okay, so that's important. So we got that one variable. We can have different powers with it, and that's all fine. But those powers are whole numbers. So things like the square root of x, that is not a polynomial, because hopefully we remember that that's the same thing as x to the 1/2 power, right? That's not a whole number. That's a rational, right? And so we can't have fractional powers or any other funky thing. No negatives. So whole numbers, by the way, are positives, right? All right. I didn't say integers. Integers are when you go with the negatives as well. So, so this is not a polynomial. And just like I was mentioning, right? If I had something like 3x to the 7th minus 4x to the negative 3rd. Nope. Because you can't have a negative 3rd power. You can't have a negative power in a polynomial. Alright? So that's another characteristic of a polynomial. Another characteristic of a polynomial is they are continuous. Alright? So what's that mean? That means as you input any x value, as the x values get bigger and bigger, there's always a spot, you're always going to have an output, if you will. And same thing as the x's get smaller and smaller, you're always going to have an output, right? So there's no holes, there's no jumps, there's no gaps, right? Or, you know, the other way to think about it is if I was going to graph it, I can graph it without picking my pencil up, but it's still a function, so it passes the vertical line test, right? Actually, I just drew that like a sine graph. Let's not do that. So things like this, and it might go on forever in those two directions, right? So they're nice and smooth, no jumps, gaps, holes, or anything else. So that's a really big feature of a polynomial function. Okay. What else? Well, some key terms. Talk about it, but key things about polynomials, like I was saying, is they're nice and smooth and continuous. And so one of the things we'll talk about in the next slide is we'll talk about end behavior. So what happens on the ends of a polynomial. These things here, right? The terns, right? So we'll call, some people call those a term. We can also call those a local max in this case, or maximum, and in this case a local minimum. And we kind of have an understanding where a lot of times we'll just say a max and a min, and we understand that it's local, right? And if it's a global, so global maximum just means that is the highest y value for the entire function. and we want to be very specific, we could then call it a global maximum. Otherwise, we often just say maximum, and we understand we're speaking locally. All right. Of course, other things we want to know, intercepts. So you got some x-intercepts. You also have a y-intercept. So those are all important things of polynomials. And those are just important things of any function, intercepts and zeros and maxes and mins and all that, and behaviors. So that's not necessarily unique to polynomial. All right. Some other things. Let's talk about notation for a little bit. So if you go to a new slide, we call this the general form of a polynomial. And so a lot of times you can use f of x, but a lot of times we like to say p of x, p, polynomial, right? And we like to say a to the n, x to the n, plus a to the n minus 1, x to the n minus 1. Because if we write it in a kind of standard form, the powers go in order from largest to smallest. And there we go. So that is the general form of a polynomial. Okay. And so the largest power is n. We also call that the what? We call that the degree of our polynomial. All right. This chunk here is the leading term. All the a sub n's are coefficients, right? But this one up here is the leading coefficient. Oops. Okay. And so that's helpful. And then a sub 0, by the way, that's a constant. Call that a constant, because it's just a number. Now, when we write the general form, we have all the parts there. So from your highest power marching all the way down to your constant. But if I give you a polynomial, all those pieces might not be there. Okay? And so let's just look at an example underneath here. So if I gave you p of x is equal to 3x to the 7th plus 4x to the 3rd minus x squared plus 10, right? So that would mean this thing is of the form what? N would be my 7, and so it would be a sub 7 x to the 7th plus a6 x to the 6th plus a5 x to the 5, right? Plus a4 x to the 4th. You get the idea, but I'm going to write them all out. a3 x to the 3, a2 x squared, a1 x to the 1st. Now you don't really need to write the 1, first power, and then a sub 0. Now if we look at it though, there is no 6th term. But that tells you that a sub 6 is 0, right? There's no 5th term. So in other words, a sub 5 is 0. But we don't write it, because why write plus 0, right? It's dumb. But technically speaking, the a sub 5 term is 0, right? A sub 4 term, not there either. So that means that that was 0, that coefficient. A sub 3, though, we do have that. And that is 4, and then a sub 7, of course, is 3. I don't know why I skipped that, but anyhow. A sub 2, yeah, I do have that. So a sub 2 is negative 1. And so that's another thing to point out, is in the general form, we do write it as positives. And that doesn't mean a polynomial always is plus, 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 plus. it just means if there's a negative, we think of it as the a term is where the negative happens. So that coefficient is a negative one, and when you plug that coefficient in, then you get a negative, right? And not a plus. Okay, so if you simplify. All right, anyhow, let's finish it off. Let's see here. My a sub 1 term, I don't have one, and so again, that's a 0. And then a sub 0 is 10. I guess I need to write this. Okay, so that's the general form. Also, this tells me what? N is 7, so the degree of my polynomial is 7. Okay. The other thing you got to watch out for, though, is sometimes you'll have a problem, and either you'll be handed a polynomial and it's not in order, or you might do a word problem and create a polynomial, and as you are expanding and simplifying, you might end up with things not in order. And so, of course, just be careful that if you have a polynomial, so let's say like f of x equals 2/3 x squared minus 7x to the 10th plus square root of 3. Alright, now by the way, is that a polynomial? Well, wait a minute, didn't I say something a second ago? You can't have fractions and irrationals and all that. Yes, I did, but that's only in the power. Okay? The powers have to be whole numbers, but your coefficients, they can be real numbers. Okay? So a fractional, rational coefficient here, and an irrational constant over here. Those are still real numbers, and so you're still okay. This is still a polynomial. It's a really ugly polynomial, but it's still a polynomial. But anyhow, the point being is just be careful. We should rewrite this in order. I mean, not that we really need to. You could answer this and all that, but it is nice, especially when you get into doing synthetic division and other things. It's nice to put it in order. But anyhow, my leading coefficient is 7 and my degree is 10, right? Those are two terms or two pieces we often want to know. And then my constant is square root of 3. That's also something we want to know a lot of times. Okay. So those are just some characteristics of polynomials. So just some real easy basics. So the next video, we'll talk about some more key characteristics. So power functions, get more specific about end behavior, intercepts, turns, and all those things. Okay, but for now, that's just some kind of general notation and some things. But check out the next video to learn more.